Hey, I'm Kyle. I'm the developer advocate from Redis Labs. And today we're going to be talking a little bit about the best practices to exceed customer expectations with Redis. Now, I am so surprised you are here because that is a really dull title, but I promise it's not going to be a dull presentation. So let's go through and talk about something that you may have noticed. This is the Redis logo, and here's what we are. We're an in-memory multi-model database. Now, what does that mean? OK, so people think of Redis as a cache, right? OK, that's fine. But really what we are is a multi-model database. Redis can be extended. It is an extensible database that allows you to create many different models to fit your data the best way possible. So the other key thing that I want to talk about today is persistence. Now, how many of you have used Redis with the persistence before? Raise your hand if you've used Redis with persistence before. OK, I'm seeing no one. So that's a big problem. Let's talk about why you might want to do that today. So with this, people use it often ephemerally, and that's great. But there's many more things to it. Now, shifting gears and talking a little bit more about how Redis works, how many of you have used Redis? Raise your hand in the audience. OK, handful, about half. So Redis uses the idea of each key in your database having an attached structure to it. So as you see on the screen, we have these structures. Probably the thing that you're most familiar with is the idea of a string or a blob, right? Very simple, easy to use. But we have many, many more. Some of these you're probably familiar with, some of them you're not. We have bitmaps where you can actually manipulate and look at individual bits in your database. You have bit fields where you can treat those bits in the database as, example, numbers. As we go down, you have hashes, which are the kind of field value store. You have a key, and each one has field that has values that go into it. You have lists, which are ordered linked lists. Then you have sets, which are your idea of sets, pretty normal. And you move forward to sorted sets. They're the same thing as sets, but they have a natural sort order to them. And then you have geospatial indices, which are great for storing things on the globe. By the way, the world's not flat. We take care of that. We calculate the entire globe for you. So additionally, we have hyperlog log. Has anybody ever used hyperlog log? Raise your hand. One person. Thank you, my friend. The idea with hyperlog log, it's the probabilistic data structure for estimating cardinality of sets. So you might want to see how many times something has been there. Well, you can do that with sets, but that takes up a lot of memory. Hyperlog log allows you to make an estimation in a very small amount of memory. And finally, we have streams, which is our new data structure in Redis. Streams are really interesting, and what they can do is allow you to kind of set up your own built-in queue that allows people to go through and read from the queue and set up consumer groups. Very interesting, came out very recently. So that's all fine and good, but no database is any good if it can't perform. So let's take a look at that. With Redis Enterprise, you can see how we're scaling, and it's linear. So what's interesting here, along the bottom, you have the number of nodes, and along the upright here, you have the number of ops per second. So I want to draw attention. Well, this is great. 3 nodes, you can get 5 million ops per second. But what happens when you go to 26 nodes? You can achieve 50 million operations per second, which is an unreal number, really. You can do so many things if you have that performance. So bringing that all together, where are we getting with best practices? So let's take a look at this. And what I want to talk about today is how you can speed up your applications with these best practices. Now, these are very general. We're going to go over 5 different things. And they're going to be very general. But I'm going to talk about why maybe you want to use these in an optionally persistent database. So first up, you have Redis as a cache. This is a really common use case for Redis. We have 2 different topologies. Here we have a look-aside cache and a write-through cache. So examples, where you have frequent reads, infrequent writes, classic caching situation, where data is shared between sessions, right? Session management is one of our most common use cases. So it's kind of distinct in many ways from actually the cache, and we'll get into that a little bit later. But examples, this is generally used with things like blob storage. So using those string data types to just store whatever you might need to store. Redis doesn't have any knowledge or really even care so much about it. But what I want to talk to you about Redis as a cache, well, a lot of people use it as a cache, but then they don't really deal with what happens when the Redis underlying infrastructure fails. And that happens. Any infrastructure will fail. We know that. We're all human. if you don't have persistence enabled, well, it can work OK. You can repopulate it. But what that's going to cause is your database maybe that you have over here, it's going to be overloaded as the cache starts to refill. So if you have persistence enabled in Redis, what you can do is actually have it come back up with a fully fledged cache. And then you don't have to worry about repopulating it or overloading your server when you're doing it. So the next thing I want to talk about is using Redis as an actual front-end database. So in this case, Redis itself is part of your entire data structure. This is where you're storing things in Redis that are maybe unique to the data that would be in your other database. Now, obviously, if you're in an ephemeral storage situation, you wouldn't want to have data that you would turn off the server for whatever reason and it happens and you lose that data. That's not something that you'd really want to do. So in this case, having persistence here enables you to have the lightning fast speed of Redis and then not having to worry about what happens if things fail. So it's a really interesting use case to have that. Now, I started using Redis about 7 years ago. And so I was using a situation where somebody said, well, why aren't you using Redis? And I said, I don't know. And I started looking at it, and I started saying, well, this is really great. And I just built my entire application around Redis, using Redis as a front-end database. And then eventually, I just didn't need the other database there, so it became a primary database. So it's very interesting what you can do when you start thinking about these topologies, when you're thinking about persistency. Finally, and we're alluded to this a little bit earlier, Redis is a session store, and this is the #1 use case we see among our customers of Redis. So Redis is actually not used as a cache as much as it's actually used as a session store. And this is a classic problem. My other kind of thing I like to relate to people is my first web application I built in PHP around 2000. I didn't understand session storage, and I built this thing that managed a retail store, and you had to log in on every single page. It was the world's worst user experience, and it's because I didn't understand sessions. But then I started using sessions on the server, and then I tried to scale out, and I realized, oh, well, I have a problem here because I need to make sure that this session state is persisted somehow among all of my servers that were behind a load balancer. There's solutions like sticky sessions and things like that, but that really didn't meet my needs as I started to scale and grow. So this was a little before Redis existed, but that would have solved the problem that I was constantly battling back in the early 2000s very easily. And we still have this problem today. So as you grow, you want to have that state everywhere that your users are and be able to be access to it no matter what maybe front-end server they're routed to. What's interesting about this when you think about persistency and durability is that Redis can be used in a situation like this, and then what happens is they don't lose their cart. That's a classic example. If you're in an e-commerce situation and you store your sessions in Redis, and then something happens to that node and you need to restore it from blank, well, people may have valuable information that they've already stored in the cart, and that's a terrible user experience for them to suddenly try to go into their shopping cart. Maybe they take a break to go to dinner or something, and come back and it's empty. Well, that doesn't say very much good things about your organization or the organization that you're building for. So in that way, persistent and session storage is really important to having a great user experience. So as we go through, another thing that I want to talk about is metering. With metering, what you're doing is you're kind of making sure that things don't go crazy. If you run an API that can be consumed by another program, you know that there will be somebody who will try to connect to your API and try to do it in a loop, a while true loop, and just do it forever and ever and ever, and will eat up as much resources as you give it. Effectively, you're DDoSing yourself, or just DOSing yourself, I should say. So with metering, what you can do is you can actually use Redis, because it's very fast, to sit in between your API and your actual information and limit that. So we have built-in counters and time to live. And what that means is when you're using it, and Redis is single-threaded, by the way, if you didn't know. When you're using it, it assures that it's always going to be there, and it's going to be in the correct order, and you're not going to have some sort of parallel problem. Now, what's really interesting about this is when you start thinking about persistency in a metering situation, you have some other challenges that you have. So let's say something fails, and you have Redis there, and it's metering, and then suddenly you have that one application that goes through and starts blitzing through things. Then it's going to fail again. and then it's going to blitz through things, and it's going to fail again, and then you're getting this endless loop. So having some sort of persistency there can really help you in a situation where you have this metering, because that becomes an important part in making sure your infrastructure is properly out there and properly available. So the other thing I want to talk about today is fast data ingest. So this is one of my favorite things about Redis. Redis is really cool because it's in memory, right? And with in-memory databases, when you think about, like, people talk about disk-based databases, and most things don't run on actual spinning disks anymore. But the problem with a disk-based database is it spins, and it has magnets, and it's got springs, and it's like a steampunk adventure novel when you start really thinking about a hard drive. But if you use an SSD, it's emulating all those springs and arms and spinning disks and magnets and all the other things that are in there. So it actually has to slow down quite a bit, because if you think about all those physical moving parts, they did have a latency that were there, and you had to write to sectors and so on and so forth. We don't have any of that legacy in Redis. So effectively, you can read and write at the same speed in Redis. So that's relatively unique. So if you're going through and writing small bits of data in a traditional on-disk database, you're going to be wasting a lot of that time actually emulating these antiquated parts that no longer exist. Well, in a natively in-memory database like Redis, we just treat everything like RAM, because it is RAM. There is no emulation layer. Everything effectively is managed the same way. So what's really cool about when you think about using fast data ingest, and then you bring all your data in first to Redis, and then maybe you store it somewhere else. So you let it take care of those peaks and valleys, right? Redis can write very, very quickly. So as your data comes in, it's being written rapidly to memory. And then as your availability of your more durable database, or whatever your database of record that's cheaper in some way, it goes out there. Now, the same thing exists here when you start thinking about persistency. Obviously, you're ingesting data. You want to make sure that you're not just going to lose that if the power goes off while you're getting a whole peak of data into it. So specifically with Redis, one of the things that we have that's been around for a long time is our pub/sub capabilities. Pub/sub is like a broadcasting message system, publish and subscribe. And it's really useful and very, very lightweight. So you just have channels, and you publish things out, and you have listeners on those channels that are subscribed, and it's very lightweight. However, it does have some challenges. It's what's called fire and forget system. So a fire and forget system it's kind of this answer of, if a tree falls in the woods, does it make a sound, right? You've heard that old wives' tale, or whatever it's called, old analogy. Well, in Redis, if a message is fired and no one's listening, did it ever exist? And the answer is no, it never really existed. So pub/sub's great. However, you need to make sure that it's right for your use case. If you need to provide some sort of durability to that, it's not going to be for you. We have the other three do have some of the same capabilities. Lists are interesting because we have they're linked lists. Anybody who did even a basic CS course probably talked about linked lists quite a bit. And with lists, what you're doing is you're inserting something in at the top, and then you're pulling things in off the bottom potentially. But the really interesting thing on the list is we have what's called a blocking list. And blocking lists will actually wait until something comes into the list. So if it's empty, it's like, hey, wait until we got something. So also really good for fast data ingest, because then you can start immediately processing something. We have sorted sets, which are, as we mentioned earlier, it's a set with a natural sort order. So that sort order can represent some sort of time. And you can use that to go through and say, give me the most recent things that have come through. And finally, and this is probably the most interesting one, is streams. Streams are our brand new data structure that came out in Redis 5.0. And they're really interesting. So, and we talked a little bit earlier, but what's so interesting about this is it's a lot like pub/sub, but it has a layer of durability to it where you can say, hey, I didn't get the last messages from the last minute or two. Can you give me all those messages? And this enables you to do kind of the same type of things that you would do with pub/sub, but with an extra layer of if something falls in the woods, it would make a sound in this case. So when we're thinking about this, what other use case can you have on this? You have an analytics pipeline. You certainly can use this to actually go in and read different things in. Then if you have IoT, which is classic, you may have heard what happens on Halloween to those front door doorbells on Halloween. They basically, everybody presses them, right? And so IoT is classic in the fact that it can have huge peaks and valleys, and you want to do some processing to those. You want to ingest very quickly. And finally, of course, log collection and time series information is also very relevant in this use case. So you might have things that are coming in not at human scale. Humans can react in what, like 100 milliseconds? Well, computers can generate log messages in the microsecond time frame rather than the 100 millisecond time frame. So all that being said, Redis can do many, many things. And as a recap, we can take a look at these. Real-time analytics, session store, all of the different things on here. We can even do complex analysis. I do want to call attention to some things on here that you may be unfamiliar that Redis can do. Certainly, machine learning we're used a lot of times in the fast data ingest part of that for taking things in from to be processed, geospatial data as well, and search. Search is one of my favorite topics in Redis. Redis is extensible, and you can plug in our Redis search module, which allows you to do full text search at the speed of Redis, and with the same dynamics of scaling that Redis has. So that being said, let's take a look of just as a brief talk about, we've talked about a lot of things here, but let's take a look more specifically at Redis Enterprise, which is the enterprise-grade version of Redis. It has true high availability, allowing you to do cover everything. If something goes down, it'll be still available. It has a built-in mechanism to prevent cache stampede. It has zero downtime scaling, which is super cool, right? You're trying to scale out. You can scale without having to wait for complex resharding to go on. Security and performance, those are givens in this case. I want to talk a little bit about active-active. Active-active is really cool. We use the CRDT, or conflict-free replicated data type, to maintain geo-replication across the whole globe. So you can have data that may reside here in Las Vegas, maybe it'll also be in New York City and Dublin, Ireland. And this will resolve conflicts without you having to do anything based on the idea of conflict-free replicated data types. I wish we could say we developed the idea of that, but that's years and years and years of academic research. Finally, we have Redis on Flash, which is the ability to take Redis and extend it beyond the simple in-memory database that you're used to. So your cold values get shuffled off into flash memory, and your warm values or your hot values are actually kept in memory. And we maintain that tiering so you don't have to. So that is a real killer. If you have very, very large sets of data, that's really, really important to you, because then you don't have to worry about scaling anything. Finally, I want to talk about how we deploy. So we have 3 deployments. We have our cloud deployment, which basically is like, I need 10 gigabytes. Please give it to me. You give us your credit card information, and certainly we will provide it to you. There's nothing that you have to do. There's no managing of servers you want to scale out. Well, that's our problem, not yours. We have VPC, which is really interesting, because what that can do, it allows you to have basically your own multi-tenant solution that is managed in your own VPC. And then we have our enterprise software solution, which is designed for on-premises or managed, and you want to manage your own infrastructure. So really cool. 3 different options you can have that all meet anything. And of course, it's available on public cloud platforms, AWS, of course, but there are others as well. So if you look here, I do want to mention Redis Cloud is RAM only, but both VPC and software available in RAM or with the Redis on Flash extension. So that's all I really had to talk about today. So I'm going to wrap it up right here. And I think we just have 1 minute or so, and if we have any questions, we can do maybe 1 question in 1 minute.
Okay, very good. If you have a question, just raise your hand, and I'll give you the microphone so everybody can hear your question.
Hi, we are looking at a use case to support a few million writes per minute.
I'm sorry, could you repeat that?
So we are looking to support few million writes per minute.
Yeah, yep.
And that perhaps fits the use case 5. We are an IoT company.
Yep.
So you said the provisioning is based on the memory.
Yep.
But would that have any implication on the number of writes we can do?
I do want to, I'll just go back real quick. So for cloud, it's based on memory, right? And we give you a certain kind of threshold on that. VPC and software are priced and provisioned differently. They're based on the number of shards that you need to support performance and size. So there's a couple of different things that go into that. So that you may have a situation, we have some customers that have situations where they need only very small amounts of performance and huge amounts of volume and so on and so forth. So that's how that works. OK, I think that's all the time we have. So thanks so much, everyone. I'll stick around if you want to talk to me for a minute. And come by our booth. We're over in the 800 section. We've got a big screen, and we'll be giving little talks throughout the day about a lot of these things. So thanks a lot.